Swayam Prabha. Digital India. Educated India.
So that's why you have to use to understand that importance of Internet of Things. You understand this, right? I think most probably you come along with this the World Wide Web. Now you are also coming along with this all those things, but you should understand. Now you are all familiar with these applications, at least in the user level. But you should, as an engineer, right? You should know about how actually this was developed. There are a lot of opportunity for job and other business. Everything is there. You can develop your own business with the help of this. So many options are there. You will become an entrepreneur. You can start your company, startup company, right? So the list of IoT devices. How many of you are familiar? Yes, please. The reason is very simple. Sometimes, if fortunately, unfortunately, if it is open, right? Once it's open, what happened that the other end, there may be a chance for sending some pop-up message to you, right? So see, they are sending keep on pop-up message to you, which will store your those information in your mobile. The storage problem may maybe come across, which also slow down your machine also, slow down your what you call your mobile also. You understand what I'm trying to say? They will keep on sending pop-up message until you get response. If you are not response, they will keep on sending the request if it is open. So like advertisement, for example, they will keep on sending advertisement. For those process itself, it will take some computational power, right? Energy will train down. For example, instead of 1 hour, the backup time, it will come down half an hour. You understand? Yes? Yeah, hacking also possible. This is one type of hacking. I want down not only your mobile, the server also. To run that particular application, some server should be there, right? Through the server only, I am sending the message to you. The server will also come down. Okay, it's partially hacking, decent hacking, right? You understand, right? So this is what the different. I think how many of you are familiar with this smart devices, the smartphones? All are having smartphones and tablets. How many of you have a tablet? Yeah, and smart home devices. The thermostat, lights, smart bulbs. You know, smart lights, smart bulbs, right? Right? Smart locks and smart doorbells, smart cameras, and smart plugs and outlets. Let me see some example. Smart speaker and voice assistant. Example: Amazon Echo and Google Home, and then the familiar one is there, right? Alexa, right? Alexa, and smart appliances like refrigerator, washing machine, oven, and smart irrigation systems. All are having small chip. The chip is nothing but something like the embedded. Some software will be written into the chip for the design, and which will work for the particular constraint based on your requirement, right? And maybe here you can see that wearable devices, smart watches. I think he's having smart watches, right? He's having smart watch, yeah, and smart watch and the fitness trackers, health monitors. So wearable health monitor. This is what you call that band, smart band. Smart band will tell you that how much calorie you have taken in the morning, how much calorie you have spent in terms of steps, or in terms of I'm speaking something. I'm speaking about this topic. I am giving some energy. Am I right? I'm moving this my hand here and there. It's something like I'm spending in some energy. How much calorie I have taken, how much calorie I have spent. Still the calorie is there. Please burn the calorie. Right? So for the healthcare. So those applications, it is also one of the IoT device for the wearable device. Connected cars and vehicles, connected car system and telematic devices. How many of you are having connected cars systems, like for example, latest system, all are connected, right? For example, so many things I can discuss. Now, I think time being, it's very difficult to cover all those things. Everything. So you can control. Maybe the connected cars, maybe I will come to this point. And industrial IoT, this is also one important. IIoT, that is called industrial IoT. IIoT, that is industrial IoT devices or industrial sensors like a temperature sensor and pressure sensor and asset tracking devices and connected machinery and equipment. So if you see that any big machinery, for example, integral coach factories is there, ICF, and the lignite, um, uh, what you call blacking, and then storing some places, and then they are having some problems. Immediately, the alarm should, if for example, smoke or fire, the sensor will detect the fire or smoke, immediately inform to that particular person. So to avoid that accident, right? So what I'm trying to say that these are the used for any manufacturing, whether it is automobile industry or any public sector industries, any manufacturing industry. Very I think n number of manufacturing industries are there worldwide. All the industries are controlled by this what you call IoT devices. We have to plug in. It's very difficult to human being monitor always. It is very difficult to do that, right? Even in the forest also, even in the ocean also, even forest and ocean, we are deploy this IoT devices. Where from that we can get some information and then we can do accordingly. So this is what the industrial IoT devices and the other healthcare IoT devices like remote patient monitoring devices. How many of you familiar medical wearables, smart medical devices? That is insulin pumps. You heard about insulin pumps, right? This is also come under what IoT devices and smart city infrastructure, smart street lights and traffic monitoring and control system and environment sensors and agricultural IoT devices, soil moisture sensors, automated irrigation systems, livestock monitoring devices, and smart energy devices, energy related devices like smart meters. Now everything is smart. For your electrical bill, need not to go before 10 years back. A human can, the particular serviceman come and then seeing the meter and then record it, and then they will send the report to the concerned engineer. Right now, it's not like that. This will automatically monitor and then it will report. It will store the information in the system, and then from that they are generating the report, and they are giving you have to pay the bill and so on. Right. So this is what the industrial automation devices, what you call energy monitoring system, industrial automation devices, the programmable logic controllers. This is also very important. PLC. You heard about the word PLC. Programmable logic controllers. Everything is programmed by some logic. Based on that, the chip will control. Right. And industrial robots. Industrial robots. Now the robots, I think, heard about robotics. Even the operation, which was done by the, which is they are planning to do that, what you call operation by the remote, what you call robots also. Robot operates in many things, right? Which will go for something like that. It detects the bomb also. In an emergency situation, the robot will detect the bomb like a dog. So, which should have some sense like a dog. It moves around in the building and it will detect the bombs and then it will inform you that the bombs is there. Right? So, where again number of IoT related devices are embedded. And what else? This connected health and fitness devices, smart scale and smart exercise equipment. I think in many exercise, what do you call, equipments are available, which also come under this IoT devices and so on. Right? See why I am giving this slides and things like that. How many of you are familiar with all the devices? It's not a matter. How many of you are familiar with all? But you definitely you know some IoT devices. Maybe you can connect those IoT devices with some other application. This is what I want, right? So you should think about it. And what happened actually? this is a compound average, what do you call, compound average grade rating. This is one Internet of Things. Connected devices, something like that in so 2021, in terms of billions. In terms of billions, now you can see that the 2021, the connected devices billions, it keep on increasing. And for example, around 25% compared to 2014. Connected devices in billions. This is what we happened in 2015. Cellular type IOT. Cellular type IOT is something like that. You heard about the GSM, GPRS, right? You heard about, right? That which come under cellular type. GSM, GPRS, and UMTS. Many jargon, many keywords I'm trying to say. Maybe you can go through that. So those come under this cellular network, and then non-cellular type networks. If you see there's something like that, just Ethernet and a fixed phone number or wired connection. Through the wired only the communication will take place, right? So those things are come under cellular network, and then PC, laptop, and tablet, and then mobile phones, and then fixed phones. In fixed phones, for example, in 2015, only 1.3, whereas in the fixed phones, in almost 2021, there is no fixed phone in. Do you have fixed phone in your home? No. Or in your office, or your father office, or mother office, or something like that, or your friends, relatives? No. Almost the fixed phones are almost closed. Not necessary, right? In 2021, almost for the cellular IoT is 27% for the connecting devices. Everything is closed, right? This is very good information, and I think this is one. How now our population in 2020 around 50 billion. 50 billion, sorry, 7.6 billion population worldwide. Worldwide, our population strength is 7.6 billion. Now, the connected devices is 50 billion, 50. Now, if you see that almost, just now I told that the connected devices per person, 2003, it's 0.08. Whereas here now the point 6.58. Now, just now I told that how many devices are connected. How many devices are connected? Every person now, minimum they are connecting with different servers. For example, you have number of apps in the mobile itself. You have number of apps. What happened? You are connecting with different servers. For example, Gmail app is there, Facebook app is there, Twitter app is there. And if you click, you are connecting with the Facebook server. If you click email, you are connected with the email server. If you click WhatsApp, you are connected with the WhatsApp server. Again, the WhatsApp server can communicate with the Facebook. The Facebook may communicate with the Gmail and so on. So what I'm trying to say, we are connecting. The average has been increased day by day, year by year. In 2021, almost 6.5 connected device per person. This is what the statistic says, right? And this is the Internet of Things and growth. I think how many of you, it is very difficult to read, but maybe try to sectors like different sectors, n number of sectors. It covers all global, including buildings, energy, consumer homes, industry, transportation, retail services, IT, and professionals. Almost which covers all sectors worldwide, globally connect all the sectors, transportation or education sector or IT, everything is connected. Everything we have to go for this internet service. And this is what how it really in our day-to-day life, we are having IoT devices like now simple digital watch, and then it becomes what? Digital watch. smartwatch, and band, smart band, switch, remote switch. Now, how many of you have used that remote switch? Very simple, but that is what you call this IOT is there, right? So simple, and then class also, smart class. Now you can adjust your class, or you can change the class. For example, it automatically when you go outside the sun, what you call um, temperature is very high, which convert into sun class automatically. You can set that. Everything is possible. You can zoom it. You can adjust the class. So that's the normal class becomes a smart class and so on. So for that we have to write a program, right? It will not have work without that program. So simple program we have to write that should be embedded in the watch, what is the class itself or the remote itself. Here they are having a number of apps also. Through the mobile I can control it. Through the mobile I can control the switch on, switch on the LCD board, right? So this is what the smart city. Smart city main objective is something like that: a smart car, smart me, that is healthcare and then fitness and wellness. So here the smart home, waste management, smart society, smart care, smart IT and communication, smart education, smart mobility, smart energy, and smart building. Everything come under this smart city. So this is one project. This is very big project. Smart home itself. Every home, not a single home. Every home should become a smart home. That's the objective of this smart city. And maybe what do you call smart care? For example, first aid, smart care. If you have any problem, immediately which will identify that you are having this problem. That will inform to you, right? Those things are come under this smart city. And this is the connected roads. This is another example. Connected roads. This come under this US Department of Transportation Statistics. What happened? If you see, there's 5.6 million crashes in 2012. 2012 total crashes in US is something like that, 5.6 million, out of which 31,000 are fatalities and 26,500 in Europe. So what happened? Over 1.6 millions are injuries and 1 trillion USD in economic losses. So here the human loss is not there, and the car, everything. You might have buy the car 1 crore, for example. If it is crashed, everything collapse. It is not individual response. It is again in turn it's a common response also, right? So 5 billion hours to travel delays per year, and then most important thing is emission, environmental pollution, carbon dioxide. It pollute through the carbon dioxide in the environment, right? So what happened that is also a major issue. So for that only they are developing one car, that is connected roadways cars with the help of radar. For example, like what do you call this? Video cameras and radar sensors, all are connected to this, and through which what happened, we'll try to avoid this accident. We'll try to avoid this accident. So maybe even those who are driving with the trucks, that immediately you can intimate that before what you call the one car is the driver is dragging or had what you call have a truck and maybe which may give some problems. Be alert. So everything is available now for your information. I'm not going to tell about the new version. Maybe they are trying to fine tune those applications. They are trying to fine tune those applications till the research is going on in that direction, right? And this is a connected car factory in one example where we have to concentrate like innovation, efficiency, and agility and risk. This is what the smart and connected buildings where we have to think about that energy management, lighting, safety, and HVAC, that is heat, ventilation, and air conditioning. That is HVAC is a heat, ventilation, and air conditioning, and building automation, and what are smart spaces. So those parameters to consider to build smart and connected buildings. So all are connected, right? For example, 5 a.m. 5 a.m. the manager arrives for a global call. So this is so earlier. Immediately they inform that so earlier. So and overnight, what will happen after 6 p.m. How the building, smart building should work. For example, thousands of people are working in the smart one building, right? Right. So those things after 10 a.m. or 1 p.m. everything we can set in the smart connected building, right? This is a smart grid. I think here you heard about the grid, power grid. So power grid is again one more thing, smart appliances, demand management, and what else? Sensors and processors and generator and so on. And smart homes. Smart homes, you can see that locks and TV and speakers. If you, for example, you forgot to switch off your TV, right? So you forgot and then you remember, I forgot to switch off my TV. Then you can, from the office, you can switch off your TV, switch off your light, switch off your fan, switch off your air conditioner. Everything we can do it, right? So this is what happened here, and then this is what the what you call security cameras. Security cameras is there, and then blinds. This is for the window, open and close, and thermostat and lighting, appliances, including oven and then fridge, washing machines, and irrigation engineering like sewage plant maintenance, plant maintenance, whether it is everything which come under smart homes, smart city. In turn, we will convert it into smarter city where we have to consider the transport also, road, connected roads also, right? So this is what the till now what I'm trying to say about some examples like a smart home and a connected roadways and so on. With the help of these examples, you should understand that the important role of IoT. Are you able to follow me? Now you are maybe you are not familiar with all applications, but when I show this diagram, you can understand it, right? That's more than enough for time being. Now you understand. Maybe you can explore whether you are planning to work in smart home or whether you are planning to work in smart grid. That's the next level. The beginning level, you understand that to bring this smart home, we have to concentrate in the smart locks, and then we have to concentrate in the TV and speakers and so on. What are things are available in the home, in the hall, everything is to consider, and how to control those devices with some remote applications with the help of internet. With the help of internet, how to control all those things. Right? That's the objective of this session. Right? Till now, are you able to follow me? Okay. So till now, what we discussed actually, just I am trying to give some IoT definition. I think you remember that this diagram, like the square diagram, where we have a IoT objects. IoT object is anything, and controller. Controller looks like it behaves like what? Brain. Controller or brain. Okay, brain. Then what happened? Sorry. Sensor. Then the sensor will interact with the controller. Then immediately what you will get? Actuate. Then actuate is happened. What happened? Network. Through it communicate. One device to another device, one object to another object, the object to object communication, and so on. This is what happened. Once it's clear, then we list of IoT devices. What are the devices that are available for many sectors? Healthcare sectors, transport tech sectors, all number of. I listed very few only, not all. Right? 3 sectors. What are the devices that are available? How many devices? Maybe this question arise yourself. Like how many devices I know actually. This is something like that. You can answer. Everyone will have a different opinion, maybe apart from mobile phone. Now, right? Next one is something like that. Some example, real example. The safe, for example, smart home is a real example. If you go to abroad, something like US, everything now becomes smart homes. Everything is become a smart homes, smart city. So we are trying to adapt from them. Right? Everything is implemented actually with the help of different IoT access technology. What are the access technologies are available? Network and access technology. You are familiar with what? Wi-Fi, Zigbee. Yes, good, very good. Zigbee. And what else? Wi-Fi, WiMAX, GPS, GPRS. Those technology, access technologies are available too, right? So some technologies maybe I can discuss with that, right? So in the next slide, we are going to briefly discuss about those technologies also, right? So this I hope this is my brief introduction about IoT, right? And this is what we actually the architecture, the overall architecture of IoT device, IoT architecture. Anything you can start with the system architecture. Once you understand the system architecture, you understand the flow. Once you understand the flow, what do you mean that you understand the logic behind it? Yeah, you know how it behaves, how it works. That is very, very important, right? Similar, every architecture will have this something like that layered concept, Like for example, application layer, presentation layer, and something like that. Every layer will have this architecture. So first model is something like that, which mainly used for analytics. The analytics which come under vertical specific apps, something like SCADA. The SCADA is nothing but what supervisory control, what you call data acquisition. Yes, good, very good. Data acquisition. And what you call MDM is one type meter data management. Meter data management. Similarly, number of things are available. Vertical specific. I am not going to discuss about this. We are going to. This is not for the class to getting marks and so on. You should understand that. And those parts come under this analytics. And what happened here? The IoT network management is come under co-op. Let me see MQTT, everything. Let me discuss in the slide. And network transport layer and gateways, and then backhaul network and access network like a FAN, LoRa, and a PLC. This is PLC. I told just now. I told that what is a programming logic controller, right? And field, what you call field area network. That is field area network. That is a FAN, and LoRa. We have discussed low, what you call low power wide area network, right? That also we discussed. And the different applications are there in the functional stack. What are the functional application, communication network, and things like a sensor and actuator will work. This is what the core IoT functional stack. So these, what you call this analytics, and then what this protocols will connected to this core IoT functional stack. Once it's happened, then we have to go for IoT management and computer stack. With the help of internet, we can connect with the cloud and then fog and edge. We have to discuss about. This is not the position to discuss a lot about the cloud computing, edge computing, and then fog computing and all. Right? Anyhow, just these are the global platforms are available for the platform for the services. Number of service providers are available, and with the help of the service provider, we can connect the IoT devices to work with the help of these protocols for analysis purpose, right? And this is what the access technologies. How many of you maybe different access technologies are available? Here, this what do you call? For example, 10-meter range, the Bluetooth, and which will start from less than 10-meter range. We can go with this NFC and EMW, and Europay, and then what you call M stands for I don't forget it, and then V stands for Visa card, right? And what is the less than 10 meter? less than 10 meter, we can use this NFC, right? Within the room, we can use within the less than 10 meter. And if it is less than 100 meter, we can go for this technologies like Wi-Fi and then 6 These are the access technologies and LoRaWAN and other things, right? Here, for example, the range not strictly defined. Where? That is WPAN. WPAN is something like that, wireless personal area network. And WHAN, that is the wireless home area network. Again, I am repeating, the range is not strictly defined here. And WFAN, this is wireless field or factory area network. And WLAN, wireless, what is called wireless local area network. And the other one is a WNAN, that is wireless neighborhood area network. And wireless wide area network. And the next one is LPWA, is the low power wide area network. So what I'm trying to say, this less than 100 meter and 100 meter, we can access the technology, and with the help of this 3GPP, that is called what you call 3GPP is LTE long-term evolution, the 4th generation network. There is what you call this project agency. So they form a group to execute this. GSM is global system mobile network, and then GPR is the packet radio network, right? So what happened? See, maybe these are the for timing. You should understand that these technologies are available for access the IoT devices, and they have given the distance range also. Timing, you could timing, just you should understand these are the technologies are available for accessing, like Wi-Fi and Bluetooth. I think you know how to use the hotspot and so on, right? Hotspot, we can connect without internet also. We can connect to the hotspot between the two machines, right? You can connect the mobile and then what you call your you can connect to the internet through the hotspot, right? So something like that. Even though you don't have that internet, you can use the hotspot for the emergency purpose. So the hotspot itself, what you call this, what they call is a access technology, right? So that those things you should remember, and these are the protocols are available. And if you see that the protocol, for example, constrained application protocol. This is a co-op is constrained application protocol, which is very familiar or which is very useful for, especially for, especially very well defined for what you call resource constrained IoT devices. Already I told that resource constraint means what? For example, speed, computational speed, storage, energy, right? Those parameters are very, very important, especially for IoT devices. It's not like a desktop machine. Desktop have the RAM speed is very high, 8 GB RAM, for example. Intel processor, so, right? Intel processor, and then what you call this memory is very high. Hard disk size is very high. Whereas in IoT devices will not have that much memory, right? Just storing and the information, and then it will spread to the next devices, and the communication will take place. This doesn't have a much memory power. It doesn't have a memory power. So how to use it, right? So those things is very, very important. Like here and messaging. For example, let me take one co-op, that is constrained application protocol. They are using transport layer is UDP. UDP is unreliable protocol. You are familiar with, right? Unreliable means what? There is no guarantee for the packet is received or not. That's it's nothing but unreliable, but a connection will be there, right? And messaging is based on request and response. Once the client is request, and then through the message response message will connect. Request and response. And 2G, 4G in terms of hundreds, excellent. That's like thousands. Low power and then lossy, again thousands in terms of excellent. And computer and resources, 10K RAM and flash RAM memory. And what else? The computer resources, sorry, security, the medium optional, and the success stories, utility field area attack. The architecture is tree-based. Architecture is tree-based. And sometimes you can say the topology, you cared about the topology, how we are arranging the systems. That is called topology, right? So the topology is the architecture, for example. Similarly, for number of supporting protocols are available for IoT application and IoT function, how IoT should work. So those protocols are specifically designed for what you call this IoT, right? So anyhow, we are going to discuss a few of them in the next session about these protocols, how it works, and then how it, the security point of view, how will it affect the system. Those things, and how to avoid it. Once just now she asked me that how to once you open unnecessary apps, what will happen? Just now I told that answer. Can you able to follow me? Right. Similarly, for this application, how we can compromise, for example, co-op, right? How I can compromise this application. Once it's they compromise, the hacker compromise that application protocol itself. So there is no guarantee that the protocol will 100% give the services. Any product, it seems like they will give 2 years warranty and 3 years warranty. That's it. Lifetime warranty, anyone is giving? Do you know any product they are giving lifetime warranty? Did you hear about it? Lifetime warranty for any product? No. Even software also. You should keep on update the software also. Again, one more thing. You didn't update the software frequently, then also give problems. Because they found some patches. The patch is what to avoid they identify the attack, then they create the patches. They will update it in the software. For example, how many of you often update your Windows or any operating system? How many days? 1 week once or every day? 1 week once. At least 1 week once you should update the Windows, for example. Otherwise, what happened that they will worldwide, assume that worldwide, how many hackers are there? So hackers is not a matter. Again, one more thing I forgot to tell you that accidentally hack may also generated. You open the bio, you give a link to some XYZ, I am linked with you. There is a chance for attacking me also. There is a chance for accessing my data also, because you linked with the particular person. So this is something like cascading effect. You understand what I am trying to say? You should update the software frequently, not only system, any software. Obviously, you might have seen that some pop-up message. You might have seen that, right? Please update Chrome. The version is there. Please update. You should update it. But you should be very careful whether this Chrome update is coming from the legal website or not. That's very, very important. The same update will be come from the malware also. You should be very careful. Same website without how many of you seen that fake notes, fake rupees notes? One. Can you identify the difference? Is it possible? No, exactly. It's the right answer. Very difficult. Very difficult to identify. This is a fake note. This is the original note. So then assume how website, similar website, SS website, similar website, certificate, similar degree certificate, 100%, but it's like similar signature, right? So that's the thing is going on. So to control all those things, you should be very careful. So anyway, we are going to discuss about some protocols in the next session. All right. So now the future of IoT connected devices in 2025. Connecting devices in 2025, which may go up to 2025, which may go up to 75.44 billion. 2025, after 2 years, the connecting devices to almost 14%. 14% will increase, 15% will increase, 13% will increase. connecting devices. Now, actually, our population is around 8 billion. Connecting devices is what? Everyone will have around 7 connecting devices every day. We are using we are using fridge, we are using washing machine, we are using every home appliance itself. After that, you are coming from the car or bike or bus or airplane or whatever may be connecting devices. And then you are coming here and then you are listening, connecting devices. Everything is programmed. Once they got the program, they can control it. Once they got the program, on the beginning itself, whether you remember or not, the program, I can write a own program to hack the information. It's very difficult actually. Because I should know about this confidentially, how actually they design this circuit. Once I got it, I can control this device. Because it's open, right? For example, I click right click, then it will go to the next slide. Again, one more person, when I click right click, it will go to the previous slide. Or they can switch off. Now he put the battery, right? Now, even though if a battery is there, this will not work. I plug it. Is it possible or not? Yes, it's 100% possible. Once it's open. The device is not having some success, whether I have to press or not. Anyone can press, right? Remotely someone can press. Or I can lock this process. Some driver program which controls this, the operating system. Some driver program is there. I can stop that. I disable that software driver program for this stick. You understand what I'm trying to say? Yes, I can control the driver programs. I can disable it because so if it is switch off and without my permission, the power fluctuation is switched off. Then the configuration may change or may not change. Without proper shutdown, assume that the machine is switched off. The configuration or settings for BIOS setup, it will change or not. For example, date and time change. Then you have to go to the BIOS setup and then you should change that all those things. Am I right? How many of you follow or not? I don't know. Right? That's why normally in your lab itself, your mentor will tell you, please switch off properly. How many of you switch off properly in your lab? I don't know. Right? Some people switch off like this. Some people, but we can't see that whether they are pressing here or so on. Do's and don'ts we'll write in the board. So what happened when I put next time I boot that machine? What happened? The configuration will completely change. What happened? Internet is not connected and so on. So those problems are case. Once that happened, what happened? The problem depends upon that the situations, right? So, so 2025, assume that we can reach the number of connecting devices, IoT devices will definitely increase, and demand is also more, and everything will something like that. Smart, I can control the fan in the remote, right? Remote fan control is there, everything. So that's the thing is that thing will happen, and finally now we enjoy the services. Now we enjoy the services of IoT. We enjoy the applications. We are using the applications. Fine. What about the next one? Service. What she said is something like security aspects. What about issues of update? You should take care, right? You should take care about your health. You can have very good food and then you can have more in the morning. You should take exercise. You should maintain your health. Similarly, we maintain the services also. To maintain the services, you should take care of the security. So, in terms of security, is a major challenge in IoT. So, we agree in 2025 or to 2035 itself, the connecting devices are more than 10 crores or 100 crores or whatever. Fine. So, what is the next issue? Security also you should take care. They can control. So, assume students and then they can control your system remotely. You just go through that your Google or maybe in the Google just to give some demo about how to hack the operating system, how to hack the Bluetooth devices. I can show the demo. I can run number of videos. It opens. Just to give that word. How to hack the operating system, how to hack the Bluetooth devices, how to hack the Wi-Fi related devices. They have given step by step. So step by step they have given clearly. If you follow that, you can hack it. So that's a thing is going on. Right? What I'm trying to say, here they are giving the attacks, take control, steal information and disrupt the register. 3 attacks. For example, completely take control of the home appliances. Completely take control of the car. Completely take control of the some man action. Or in the meantime, steal the information from here. Steal the information from the car. Steal the information from some common source. And with the disturbance, we can disturb the what you call the smart door here. Or you can disturb the car also. For example, maybe what do you call this connected cars. I can disturb the car also. I can next slide. I want to show 2 minutes video, and I can disturb the what you call the services also, right? So this is what happening in one. So just a small demo, not demo, video clipping, which is available in the net it seems, and just I'm playing this video.
Like many thousands of Jeeps around the world, it can be remotely hacked over the internet through a cellular connection to its entertainment system.
Andy Greenberg, senior writer at Wired, allowed 2 hackers to remotely control a 2014 Jeep Grand Cherokee that they say hadn't been altered in any way while driving on a highway in St. Louis.
So first we're going to turn the fan on him.
Yeah, let's turn the fan on, see if he even notices. All right, something just turned on, all the fans and AC and stuff. I didn't do that. Okay, now the air conditioning is blasting, the music is blasting, and I can't see anything because of the windshield wiper fluid.
Hackers Charlie and Chris say they worked for the last year to develop the software to take over the digital systems in the vehicle.
So we're killing the engine right now.
It says park I turned on my hazard lights, but I was still stuck in the right lane with no shoulder to escape onto. Guys, I'm stuck on the highway.
What did he say?
I don't know, I think he's panicking.
They say this experiment was done to show how some late-model Chrysler vehicles could be exposed to hacks through an internet-connected computer in the dashboard.
We wanted to show that this attack has serious consequences for this vehicle.
We're only 2 guys with 1 car, right? So, we can't look at every car, and we want to release this information because more people like us need to be focused on this problem.
Charlie and Chris alerted Chrysler, who is offering a security update at no cost to customers. They released a statement writing, similar to a smartphone or tablet, vehicle software can require updates for improved security protection to reduce the potential risk of unauthorized and unlawful access to vehicle systems. Be sure to watch Inside Edition.